There are many different types of transistors seen as in this picture here, and we'll be looking at the transistor circuit now in relation to an NPN transistor with 3 pins on it: emitter, base, and collector. Now, a transistor does two things. It can amplify current in a circuit, and it can act like a switch. So when a switch is on, it amplifies current, and therefore our output can operate. How does it turn on? Well, when the voltage gets greater than 0.6 volts, the switch connects and the rest of our circuit can now operate, and our output up here will turn on. So let's have a look at this circuit here. We have our potential divider here, which we can control V out along this rail here into our transistor. So when the fan comes on, or the fan comes on when the temperature gets too hot, in this scenario here, the fan is on, so let's see what our temperature is. It's 46 degrees. So let's start with our temperature down low. Let's have a look at current and voltage here. Right, so voltage into the transistor is 0.5 millivolts, or sorry, 558 millivolts, which is just over half of a volt going in. So that's not our 0.6 required to switch on our transistor. And the current over here is 48.67 microamps. Okay, which is very low current. So let's increase our temperature. Let's get it up there, 44 degrees. And our fan is on. So our transistor has now switched on and amplified current. Yeah, and we have 1.3 volts going into the transistor. That's enough to switch it on. And we have a current of 101 microamps, which is enough to drive our motor and fan and keep our room cool. So the sensor detects heat and reduces its resistance, as we've seen before, allowing more voltage to flow, and therefore V out increases and switches the transistor on, which connects the motor back to the ground rail and completes the circuit.